Good morning, everyone. Hey guys, good morning. So we have got 31 people here. All right. Um, can you confirm that you can see my screen?
Yes, sir.
Yes, sir.
Okay. So, how are you guys? So, what we have seen in the last class? We have seen few concepts. We have seen types of data structures. And then we have seen that it is very important to select a proper data structure before proceeding with your project, right? I mean, so we have to select if you want n number of records to be inserted in the runtime, then you have to go for some kind of data structure called list. Right? You can't use array in that. And what we have seen types of data types like primitive, non-primitive. I was disconnected in between due to internet issue. So can you tell me where we are until until which slide we have seen? Hello? Can you guys hear me? Can anyone confirm that am I audible?
Yes, sir.
Yes, sir.
All right. So
Yes, yes.
I'm just asking until which slide you have seen.
Sir, from the start, you not haven't shared the screen.
No, someone said that it is visible. That's
Sir,
why I have.
after that you disconnected.
Oh, it was disconnected. Fine.
Yes, sir.
Okay. So I hope my presentation is visible now.
Yes, sir.
Yes, sir.
So we were here, right? Can you see abstract data type slide?
Yes, sir.
Yeah.
Yes, sir.
Yeah. It's going on. Uh, so guys, give me 2 minutes. I'll just rewind and then I'll get back to you. So I was talking about abstract data types. So which means that we're gonna hide the implementation. So I was giving some examples like, um, for example, if you are adding two numbers, let's say C equal to, I'm just saying A plus B. Okay. So which means what happens is that we will simply get the output for this. Like you can print it, print the variable C, so that you will simply get the output. I mean, it will add. So which means I'm saying that this plus operator which we have used will automatically perform the task of addition, right? So we are not going to look into the code which is running in the background, like how it is going to happen. Likewise, if you want to perform any like multiplication or division, so you just use the operator, right? So that it perform the task for you. So we are not going to worry about how it is going to perform. That's what about ADT, abstract data type. So which means we need to hide something from the user. I mean, we're going to hide something from the user because the user don't want to see all such things. So what we do is that satisfied is given in the first point, focusing on what it does, which means if you use plus, it will add. So that's what you should focus. So and you're going to ignore how it is going to do that in the background. Fine. So likewise, that is what I have given as an example here. As a stack, um, in stack, we will perform insertion and deletion. That is called as push and pop. So if you want to insert, you want to call the function, this particular function push. So which means it will automatically insert records for you. So and again, we are not going to worry how it is going to insert in the background. Okay, so some part is hidden for the user, because if everything is given to the user, I mean if everything is open to the user might do some manipulation. For example, I'm saying that I was talking about this plus operator and it performs addition. For example, if this is not hidden, I mean the coding part for this plus which is happening in the background is not hidden, it is open. And what the user can do is that they might change this, right? Instead of, if some user uses plus, it should basically divide. I mean, it should basically divide two values in the background, which means then we will get the wrong results, right? So this is how it is. So we can hide the sensitive information from the user, like we are using online application. If you want to download Aadhaar card, so you just want to enter your number and OTP so that you can download a copy of Aadhaar card, right? But that particular website is not going to show you from which database it is coming from which location it is coming from, and all, right? So these things were hidden. So that's what I'm saying. Are you getting what I'm saying?
Yes, sir.
Yeah, that is what given in this point. Fundamentals of how the data is stored is invisible to the user. So if it is visible, everyone can access the database, and then they can perform anything, like they can change the values easily. So that should not happen. So in that case, we will use abstraction. Abstraction in the sense hiding. That's the keyword you need to understand. So when we go for OOPS programming, like C++ and Java, we mostly use this abstraction. Okay. All right. Then I was talking about algorithm. Basically, algorithm is set of instructions, which we use to solve a problem. It is also called as a blueprint, right? Where you will have, how to start and what to process and what calculation to perform and what loops to be repeated and the end of the program. So that's how it goes. So in this, we will try to analyze like the time and space required for a particular program to execute. So algorithm has got three main things. That is, it should be in a sequence. And then if you want to do, for example, sometimes you will say that repeat step 6 or step 5, or you will have some decision making things where like switch or anything you can use over there. So it will, based on your condition, it is going to decide on which one to execute. And then sometimes you will say repetition, like step 6 to step 3. If the condition is satisfied, you will write simply repeat step 6 until it got satisfied. So this is how we write algorithm, and then we include these three key features like sequence, decision, and repetition. So these stuffs are basics, and here a simple algorithm is given to find the sum of n numbers. That is simple. So this is how it goes. So I have written 7 steps. Like first I'll take the input, then set, and then see here I have written repeat step 4 and 5 until this satisfies, right? Until our ITR less than equal to n, which means it takes my input over here. So it is going to check, and then finally I'm just printing it and end. All right. So now I was talking about time and space complexity in the in the very first class. So which means that time complexity in the sense it basically finds the running time of a program. So if you have given a n size of input to a program, and then now you should understand that how much time it is going to take to execute that particular program. Again, time can be measured, like for example, if you use, for example, there is a for loop I equal to 0, I less than or equal to 10, I plus plus, and then again there is one more for loop, j equal to 0, j less than 10, j plus plus, which means that it is going to, how many times it is going to repeat? Obviously 20 times, because the I for loop execute 10 times, j for loop will execute 10 times. So this is how we will measure, and we will consider the how many statements you have used in a program. So this is about time. So which means we are just going to predict the running time of a program. And this is about space complexity, which means how much memory is required for the execution of a particular program. And here, when it comes to space, we have two things. That is, one is, space complexity is dependent on these two things: fixed part and variable part. So in this fixed part, see, both depends on the problem, and you see this instructions, constants, variables, and all these things comes under fixed, which means that if you are doing a program, if I want to add 2 numbers, then I will say that I require 3 variables, where 2 variables are used to take values, and I will store that one in another variable, and then I'll print it, right? But when it comes to variable part, where based on your dynamic value allocation, your requirement might be changed, have some changes. Like some users might, require more memory. I mean, they want to insert, they want to store a lot of records in their program, which means they eventually require more space. So it depends again on the program. So which is we will apply, a recursion concept in that. So this is what about time and space complexity. Until this, I have seen. I mean, we have seen in the session. So, okay, I'm connected. Fine. So now let's talk about this best, worst, and average case. So I was talking about best case. Um, so best case in the sense like, we used to say that how fast, what is the least uh, requirement is required for a particular program. So that is called as best, we used to say. And in real time, I was talking about worst case. Okay, so I'm just saying that best case, worst case, and average case, we need to predict like what is the best time and space is required for this algorithm, and then you have to say that what is the worst case. For example, if you want to install this particular software, you need maximum of this size, maximum of this much RAM. So that is the uh, worst case, which means uh, so we need to ensure, so we need to ensure the program will work, but it will take how many number of times, I mean how much number of time and space is required, I mean the maximum space required, maximum time required for that particular thing. But in reality, when you want to predict the worst case, sometimes, so you need to run the program in your PC, then you need to calculate it, right? I mean how long it is going to run. Sometimes it will take years to predict the worst case, because worst case in the sense, it might, best case in the sense, immediately we will get the result, maybe in 30 minutes, 1 hour. But worst case in the sense, depends on the program, it keeps on running, then we have to wait for it. So that is why we need a formula to calculate this, because we can't wait for years to calculate that worst case scenario, right? So based on your statements, how many functions which you have used, how many variables you have used, so based on that, we will just have you heard about this keyword exponential 10 power something? So that's how they make it. So they will just take a part of your program, and then it can be found out, and then they will write that exponential, this much exponential time it takes. So that's what given in this worst case. So here it is, you see this, the worst case execution time is often of particular concern, since how much time it might be needed in the worst case to guarantee that the algorithm will always finish on time, which means that best case you can easily predict, but worst case it will take a lot of time to predict, but anyhow you have to ensure that how much time it has taken. So now here there is a explanation for best case. So what is given here? The way of an algorithm behaves under optimal conditions. So you have optimized it, and you will say that this is the minimum time required, minimum space required. So that is called as best case. Okay. So the example of this best case is, we have seen linear and non-linear somewhere. Do you remember that? So what comes under linear? Huh? Yes, arrays, which means that it will be in a continuous form. That is linear. Non-linear in the sense it will be in a hierarchical form. That's what we have seen. Now, see the example. Read the example clearly. The best case of a simple linear search, continuous search, on a list. List we have seen, a linked list. Okay, so I'm searching for something, but that is available in the first question itself. So what is that case? Is called as, see, there is a list of 10 numbers, 10 boxes, 10 nodes. Each box is called as a node, no? That's what we have seen. So I'm looking for some number. I mean, I have created a list of 10 numbers. Then I'm looking for some number, but the number should, I mean, the program should go there and search the complete list, right? For example, 1 to 10 numbers are inserted. Okay, now I'm giving input. go and search number 1. Where is number 1? But while searching, it will start from the first, right? But the 1 is available in the first question itself, which means it's a best case, right? Because it don't want to search other 9 things, so it don't want to waste the time. So that is called as best case. But in case it is not available, it is available. I'm looking for number 10, which means what it should do, it should enter to first, then it will check 10 is there or no. No, 10 to third. So likewise, this is the worst case. So it executes that particular number of times. So for example, you are saying that it is I'm having 200 crore of records, and then I'm looking for something like that. So it takes a lot of time. So based on this, you have to select the proper algorithm. That's what my concept is. Okay. So we have different algorithms. Searching, sorting algorithms are there. So like BFS, DFS, and for sorting, I was talking about quick sort, merge sort in 5th unit. So when we come to when we learn those things, you will understand these things better. So I'm just giving you what is best, worst, and average case. Okay. Okay. So I'm looking for number 10, and it is taking 10 times, and then that's why I said that we go off n. N depends on whatever the numbers, how many records you have got. Okay, it depends on the records. Okay, so now how about average case? So it is somewhere, for example, if I draw a okay, so this is a graph, and then I'm saying that like this, there is something like this. Okay, this is like time, and this is like number of repetitions. So now from this graph, what you can see from this, 3 lines are there. 3 arc, we can say. So how can I say which is best, which is worst? For example, this graph is for a small program, and I'm executing, and then I have got 3 things: best case, worst case, and average case. Now, how can you say that which is best? Why? Because it takes less time and it is fast. So best case always relies on lower bound. This is called lower bound. And what is this? Because worst case. So the maximum time it has taken to predict something, that is worst. Then what is in the middle? That is average. You just find the best and worst and find the divide by 2. That is the average. So you can say we can ensure that at least this is the average of average time and space required for a particular program. This is how we so this can be done using a simulation software or anything. We are not getting into this. You will learn this one later in upcoming semesters. But I'm just giving you an idea of what it is. I'm having a graph of this also so that you can understand the same graph. Okay. So now again, worst case. So you are clear with here what is this worst case execution and best case. So I'm just pointing this point. Can you go through the second point? So where it comes? Lower bound, upper bound, obviously, right? Because that is the maximum time it has taken to execute. So which means why we are finding that worst case? We have found best case. Okay, we can stop with that now. Why we need to find the worst case of the algorithm? For precision. Yes, and also go to the third point. It is there. The answer is there in that. This provides an assurance that this algorithm will never go beyond this time, right? So this is the maximum time. Maybe I said that 1 year, 2 years. Okay, it will take 2 years only to execute something. It won't go more than 2 years. So that is what we need to predict that, right? So that is basically worst case. So now again, average case performance. So I said that you just want to find best and worst case, and then from that you can take an average of that. So which means this running time of an algorithm is an estimate of running time of an average input. So which means that you will just find the average of both. So when you find best and worst. So what is given here? The second point. So it specifies the expected behavior of algorithm when input is randomly drawn from a distribution. For example, I have random numbers. Okay, then I want to insert all these things into anything, stack, queue, or something. Then what I do is that distribution, in the sense, like in mathematics, you might have heard about this normal distribution. The graph might go like this. Have you seen that? Maybe you will. Do you have probability paper? Probability in statistics. In that you will learn normal distribution. The data is normally distributed or what. So from that you can take a sample of data. See, we can't analyze the whole data. We will simply, we have a population of 130 crore. I want to perform something. I don't want to, execute all the, whole population report. I'll just take samples from, from Gujarat, I will take 1,000 people information. Then from Rajasthan, I will take 1,000 people information. Then the data set is minimum, small. Then I can easily execute this scenarios. Then I would say that, yes, this is the best case, this is the worst case, this is the average case. That's simple. Right. So because it suits for, because I have taken the sample from that particular data only. So it suits for that. Because if you run the whole information, again, I said that to predict this worst and average, it will take a lot of time. So this is how the graphical representation goes on. So here, this is like your input size. I said about the data, right? The size of your data, and then this is how it goes. The best case is in the lower bound, and the upper case will be the worst case, and there is average case. Okay, so now there is something new. So with this, we will end this topic. Time-space trade-off. Have you heard about cutoff? Yeah, minimum requirement. Like, I don't know whether it is applicable for you or not. After your higher secondary, if you want to enter engineering, they will say cutoff. What is that? Physics, maths, they will count, they will divide by, yeah, three main subjects they used to take, science subjects, and so you should satisfy the minimum requirement, right? Yeah. So here, what we are trying to do is that here time and space trade-off. Under this, see, you might require more than one algorithm to apply for a particular problem. Okay, sometimes you want to take more time but less space. Sometimes you want to store more data, but you want to take less time to execute it. So in that scenario, then you have to go for two different algorithms. Okay, so which means that is what given in the first point. You will be using more than one algorithm to solve a problem. Yes or no? Because if I develop a huge project, then I can't rely on one single console, right? I have to implement a lot of functions, a lot of libraries, right? And even algorithms I'll be using. I'll use searching algorithm. I'll use sorting algorithm also. Because, okay, so there is a Google form. I'm just sharing you, and then I'm asking you guys to fill. Is it? You will simply fill randomly, right? I mean, everyone can open the form. So he might open right now. He might open after 2 minutes. But he might be roll number 10. He might be roll number 1. Right? He has opened after 10 minutes. Then he will fill the form and submit. So, but he has filled it right now. So, which means his record will be there, and then I'll be having his record as second record, right? Are you understanding what I'm saying? Then what I want to do, I have taken a huge, for example, 70 students. So let's say 70 MB has taken. Okay. Then what I have to do, if I want to avoid the confusion, I want to sort it as roll number. Then I will find that, okay, this roll number is absent. This has enrolled in this particular program, right? If I sort, it will be like in a order, so that I can easily find out like who have missed, who is not in the list and all. Fine. So that apply. different sort of algorithms for a particular problem, is it? So here, this is what I said. What is given in the second point? One may require less space and one may require less CPU time to execute. Yes, I mean, how much CPU cycles you have taken, that is what about space, right? If you take more CPU cycles, I mean, if you are processing huge, if you are running a huge software, let's say Visual Studio .NET, which means it requires at least 2 GB of RAM, so it will occupy your whole stuff, so which means you require more space, right? And that requires more time also, because it executes a little bit slow when compared to other IDEs. So this is where both this time and space trade-off comes in. Okay. So how about this point? So if space is big constraint, for example, for me, I have less number of, less space in my laptop, then what I should do? Obviously, I had to go for some other IDE. That's why I'm using Turbo C++. I'm not using some other thing. That's what given, na? So accordingly, you can choose it. If you want less time, then go for that kind of algorithm. If you want less space, then go for that kind of programs, right? Because I checked it, I have tested it, and then I know that which is best. I'm just saying that about software. So I'm saying that Turbo C++ is light software, so it will run very fast. It uses less GUI, graphics, and all, so that the time is also small. And then I can say that the worst case. But if you use some other heavy softwares, then I can give you that example, right? Simple. You can correlate with that. Simple. As simple as that. Okay, so now let's get into a little bit of formula. So this is denoted as time and space complexity is, we used to say function. I mean, f of n equal to g of n, we used to say. And it depends on the input size. The n is about input, right? So so there are a lot of algorithms. I said that we're gonna look into those algorithms in upcoming units, and then for each algorithm we will find this order of n, order of n log n, like logarithmic, exponential, it is cubic or what. So there is best and worst case time complexity for all the algorithms which we're gonna see. Okay. So again, I was talking about this big O. So it's here. Okay. So this is how we will express time and space complexity. We will use f of n, I'll show it here. So here, big O, it provides upper bound of the complexity. Like if you want to calculate the upper bound, you will say big O of n or n square if it is going exponential, right? Then I was talking about algorithm efficiency. I was talking about repetition of loops. So if I repeat a loop for more than 1,000 times, 100 times, will it take more time? Obviously it takes. So over there, if possible, you just apply optimization. Sometimes we will write a program in a loop. There will be something. It should go and fetch value somewhere else in the top. It again takes a lot of time, right? So which means we have to put everything within that particular loop. Fine. So that's how we can optimize a particular algorithm. So what is given in the second point? That's what I said. So running time might be differ based on recursion is about repetition, right? So while repeating, the loop is itself taking a lot of time, but it is fetching some values from somewhere, from other function or something. So it obviously takes a lot of time, right? So here comes the difference. This is called as linear loops. So how many times this particular loop will be executed? 100 times. So let me take the factor is 100. Let's take it takes 100 seconds. Okay. Then how about this particular loop? 50. So which means here the formula will be f of n equal to n, which means how many number of times it is taken. So here we will divide that by 2. So which means it is obviously reduced to 50%. Fine. And how about nested loop? So So how can we analyze a nested loop? So there will be a lot of, inner loops will be there, a loop, inner loop, and out. So does it depends on the outer loop depends on inner loop, or the inner loop depends on outer loop? Inner loop depends on outer loop, is it? So that's again, if you have used any of the outer loop value, like the outer loop is I, and then I have used I inside, so which means it obviously depends on I only, right? Then we say outer loop is depends on inner loop, right? Sorry, inner loop is different, dependent on the outer, because I have used that particular loop value inside. So if the loop is false, then it won't go inside, then it will come out. That's how it happens. So here we will do this number of iterations of inner loop. I want to just calculate how many times it loops, then multiplied by number of iterations in outer loop. So both loops, I have used two loops, then I'm just calculating it, and then I'm finding number of iterations. It will execute 100 times, it will execute 100 times. So 200 times it says. So this we have used, this type of loop we have used. This is called as quadratic loop. Is there any difference? So if both iterations are equal, this execute 10 times, this execute 10 times, and then it performs something. So in that case, we can say that f of n equal to n square. And there were 8 different, big O notations. It is like a cheat sheet, like for GTA gaming, there will be cheat sheet, shortcuts we use now to get the life and all such things. So I'll just let you know that. Okay, so we have 8 things. We just want to remember. It's like a formula. You can simply apply whatever the question is given, and then you can find the answer. Okay, so now is there any difference in this loop? The earlier one is quadratic loop, and here I'm saying that dependent quadratic loop. Why? Because that j is dependent on I, right? Battery low. Yes, what I was saying. Yeah, and how many times it executes? 10 times. And then what will be the average if it is executing 10 times? But what I have done here, the inner loop will be executed as what? So if it is 55, then the average will be divided by 10. Then I will say that the overall function, I can apply n into n plus 1 divided by 2. Then I will say this is the average of that. So this is one type of thing. And there is, again, this can be represented as big O. So see, if you are trying to analyze a particular algorithm, it is very hard. But if you are going with this notation, big O of n, big O of 1. So I was talking about, I was telling about something, like I'm just searching for an element, but that is available in the first question itself. So in that case, the big O notation is 1, because it is the best case. And then I'm saying that the worst case is like big O of n, because it is going to search all, all the possibilities available. So for example, if the size of my array is 100, then it should loop 100 times, or it should fetch 100 times. So in the next session, I will just let you know this one in brief. We will see what is big O, and then I was talking about that exponential and all such things, right? I'll just let you know what that one. So so can you sum up what we have seen today? Yeah, I want to point this thing. So why we are calculating big O? So can you go to the second point? It tells us how the algorithm grows with size of problem. So I want to just understand this particular algorithm, how long, how much it is going to be complex. So I will find this. So based on this. But we haven't find anything still now. We are just looking this one in a theoretical way. Fine. So we will apply this so that you will get to know clearly. So this the time is over. Anyone is waiting outside? Okay, so guys, quickly post your attendance in the chat box. Huh? Yeah, 103. Yes. 99. 106. 100. 87. 84. 70. 109. 114. And